In this first item, we are trying to essentially figure out what the Euler or elastic buckling load is for a column when it's braced differently in its two various directions. Note that we're given a W10 by 60, so since it's a buckling problem, let's go immediately and get pertinent values and information from there. We're going to need the radius of gyration for both the x and the y axis, and this W10 by 60 is way down here in fine print at the bottom of the column, or the table it is. 4.39 and 2.57 are the respective values. So Rx equals 4.39 inches and Ry is 2.57 inches. If we need the I itself, we can figure that out in a moment. But note here that the Euler load, or P critical or P sub E, is equal to pi squared EA over the effective slenderness ratio for the particular direction of interest. Okay? And since all we want to do is find the ratio of two different loads, that would be PEX over PEY, notice that a bunch of things will cancel out. Pi squared EA, for instance, and both of them is going to cancel out. And since the only thing left is the KL over R, and I forgot to write the square value, that's really important. But that's in the denominator, so we'll get a flip-flop here of one over the other. There's the X1 is down there, and the Y will be up on the top. This will certainly shorten our work quite a bit. Right? And so we go look at the X direction. KL over Rx is going to be a total unbraced length of 27 feet, and the K value being pinned there will be 1, and we need the Rx 4.39. Now normally I would convert the feet into inches, but we do that in both of these and it would cancel out, so we can actually even save a little additional time even with that. 27 divided by 4.39 is 6.15. That'd be feet over inch as a ratio there. KL over Ry, the only one that's really going to matter, is going to be the one that's the weakest. Now you could say, since there's two, don't we have to get both? But the weakest one is going to be the one that has the largest scale over R, and so we get an Ly down at the bottom of 15 feet and Ly at the top at 12 feet. We get fixed pin, and fixed pin for K is going to be down here, one end pinned, other end fixed, no sway. We get a theoretical value of 0.7. So Ky equals 0.7 for both cases. Right? So that would be a buckled shape that would look like that. No rotation at either end, rotation in the middle. And so that means that G, the one that governs, is going to be this one down the bottom, because that will be the largest or the weakest. So we'll get 0.7 times 15 feet over 2.57 inches, and that gives us 0.7 times 15. That's 4.09 feet per inch. Okay, so now the value that we were after here then becomes the ratio of 4.09 over 6.15 quantity squared, and that straight ratio is 0.664, but we need to square that, and so we get a ratio of 0.44 for our answer.